Hi, in this video we cover the topic relations and functions. This is a continuation of chapter 1 of real analysis series. The name of the chapter is Preliminaries. Here's a quick outline of the topics we are going to cover in this video. The first is Cartesian product. We will see definition and some examples, and then we will talk about relations. Then we move to functions, and then we see graph of a function. Very well. Here's a definition of Cartesian product of two sets. Given sets A and B, the Cartesian product of these sets is defined as follows. It's denoted by A cross B, and it is defined as the set A comma B, where A is an element of set A and B is an element of set B. That's it. That's the definition of Cartesian product. Now, to understand it much better, here's an example. Suppose set A is given by elements A, B, C, and set B is given by numbers, say 1, 2, 3, and 4. Now, their Cartesian product A cross B is the set of all ordered pairs of the form A with 1, then A with 2, then A with 3, A, comma 4, and so on. You can keep on listing all possible pairs, and after completing that, we have the Cartesian product given by this. Now, another way of looking at the Cartesian product is through a diagram, which is easier to visualize. Say we represent set A and B as follows. Suppose set A is represented by this region and set B is represented by that region, and denote the elements by these points. This is A, B, C, and the elements of B are denoted by these points. 1, 2, 3, 4. Now the pairing is defined as follows. A goes to 1, then A goes to 2, then A is paired with 3, and A is paired with 4. Similarly, B is paired with all these numbers, and so is C. So this is another way of visualizing Cartesian product. Very well. In fact, now that we have defined Cartesian product of two sets, you can similarly define Cartesian product for three sets, A cross B cross C, or for finitely many sets or infinitely many sets in a natural way. Very well. Let's move on and consider the concept relation. A relation from set A to another set B is a subset of the Cartesian product A cross B. That's the definition of relation. Now here is an example to give you a concrete idea how the relations are defined. Now consider set A given by A, B, C as earlier, and B is the set 1, 2, 3, 4. Now to specify a relation between A and B is to give a subset of the Cartesian product of these two sets. Here's an example. You take R to be the set of following pairs: A, 1, B, 2, and C, 3. Pictorially, it can be represented like this. ABC, 1, 2, 3, 4. A goes with 1. Another way of saying is A is related to 1, B is related to 2, and C is related to 3. Here's another example. You consider sets A and B as above. Now in the previous example, we saw that each element of A is related to some element of B, but that is not necessarily the case for any relation. For example, this relation, here A is related to 3, the other two elements B and C are not related to any other element of the set B. And pictorially, this relation is represented as this. Here A is related to 3, the other elements are not related to any other elements. Very nice. Another related definition, the set A of this relation is called the domain of the relation, and set B is called the codomain of the relation. Very well, moving on. Let's talk about functions. Here's the definition. A function from a set A to another set B is a relation with condition that each element of set A is related to a unique element of the set B. Here the thing to emphasize is that every element of A is related to a unique element of B. So a function is a special kind of relation with these conditions. It can be thought of as a black box. Say I denote this box by F. It's like a machine that takes input A and gives you output F of A. Now the input should be any element of A and the output should be a unique element of B. Now let us consider these previous examples. In example 2, we know that from every element of A there is a unique arrow going inside the set B. That is why this example is a function. But example 3 is not a function because there is no arrow going from either B or C. Now when it comes to denoting a function, it is usually written like this. F is the notation for the function and colon A arrow B. Here's an example that you might already be familiar with. We know that we can define a real valued function from R to R, and one such function is f of x equals x squared. Another related concept is the range of a function. It's defined like this. It's the set of all B in the codomain such that for some A in the domain, f of A is equal to B. That's how you define range of a function. So it is the set of all the outputs of the function actually. Alright, moving on. The last topic of this chapter, graph of a function. Now suppose we have a function f from A to B. Its graph is defined as the following set. Graph of f is all those pairs A, comma, f of A, where A is taken from the domain, is an element of A. That's the definition of graph of a function. And the definition actually coincides with the graph we are actually familiar with from elementary mathematics. For example, consider this function that we are already familiar with. F of x is equal to x squared. We know how its graph looks like, right? Let's draw it. Here is x-axis, here is y-axis. The graph of this function looks like this. And how do we actually obtain this graph? We actually plot these points, and these points are x, comma, x squared. So if you look at this graph is nothing but the set of all these pairs x, comma, x squared, where x is taken from the domain R. And this is the definition of graph.